Yeah, hello everyone. I'm Mr. Debayo. Welcome to my YouTube channel. Um, all we do here is to look at questions from various exams, ranging from Waec to NECO to JAM to YGCSE, and to deal with some very tough questions. I understand that there are really some questions that are giving students a lot of headache, and then they really need help. All right, so that's what I'm going to be doing here. I'll make sure from time to time I bring up such questions and solve them. We'll look at the questions together. All right, so today we're going to be looking at this question in one of the classes I had recently. So I submitted across a question, and I seen it. I know it's a question that might likely give a lot of students a tough time. So it's from Waec 2015, Further Mathematics. It's question 11B, so you can look at it in your past questions compilation. It says the first, second, and fifth term of a linear sequence are three consecutive terms of an exponential sequence. Okay? If the first term of the linear sequence is 7, find the common difference. Find the common difference. So we want to look for the common difference D. All right, so quick one. Oh, I believe you know we have AP, arithmetic progression, also known as the linear sequence. That's where you have the common difference. But for GP, also known as exponential sequence or geometrical sequence, have it that way. That's when we talk about common ratio. All right, so the thing with this question is that the first, second, and the fifth term of the linear sequence are three consecutive terms. Now, every time you find the word consecutive, it means they follow one another consecutive, like saying 1, 2, 3 consecutive integers. 1, 2, 3, like saying consecutive odd numbers. 1, 3, 5, some consecutive even numbers, 2, 4, 6, 8, and like that. That's what that word consecutive means. So when we're talking about consecutive terms of an exponential sequence, that means you're talking about something like this. Okay, so I have to leave this page now so I can get to my whiteboard, and then we can really start solving. All right, so we're talking about something like this. So you find the word consecutive for a GP. We're talking about something like this: A, AR, and AR squared. So this is an example of three consecutive terms of a GP. All right, in no particular form, in the sense of the arrangement. Right, we're not sure whether it's the first, second, third, second. But the thing is this: what we understand from that question is that the first, second, and fifth term of the AP, it kind of corresponds to the arrangement in an AP. That means it won't be out of place for us to say that the first term is A. All right, okay, so let's take the first term is A, that's T1 is A, and the second term of the AP, T2, that's A plus D, and the fifth term, T5, that's A plus 4D. All right, now we're given the first term. All right, so that means this is 7 plus D, and this is 7 plus 4D. All right, this is 7 plus 4D. Now, if these three terms of an AP correspond to three terms of a GP, that means that we can as well say that following that arrangement, we can as well say that T2 over T1 will be equal to T5 over T2. Now, why am I doing this? I'm doing this because from the question, we have it that the first, second, and fifth term are three terms of it. So let me take this now as the first term of an AP, and I take T2 as the second term of an AP, and then I take T5 as the third term of an AP. If I take it that way, that means I can have T2 over T1 equals to T5 over T2. Remember, because in a GP, that is obtainable, right? So that brings me to this point. Now, the next thing I want to do is to bring in these values into this expression. Bring in 7 plus 7 plus 4 into this expression. Okay, so let's do that. To extend this. All right, so if we do that, what we have is that T2 over T1, T2 is 7 plus D. So we have 7 plus D over T1, which is 7. That's going to be equal to the fifth term is 7 plus 4D over the second term, which is 7 plus D. All right, quick one. We're going to cross multiply. So here we have 7 plus D all squared. That's equal to 7 into bracket 7 plus 4D. All right, so going forward, if you expand this, what you have is 49 plus 14D plus D squared. All right, so that's equal to 49 plus 7 times 4D, that's 28D. All right, so we're at this stage. Now, if I move 49 to this other side of the expression, what will happen is that I'm going to have 49 minus 49. So it's like these two 49s are, they are going off the whole thing. And so what I'm going to have left is I'm going to have 14D, I'm going to have D squared, and I'm going to have 28D here. Okay, so let me pop up a new page for us to have that. All right, so I'm going to have 14D now plus D squared. So now that's equal to 28D. Okay, so let's try and do some arrangement. We say D squared plus 14D minus 28D equals to 0. All right, so D squared minus 14D equals to 0. All right, so I'll have D into bracket D minus 14 equals to 0, which means that D is going to be equal to 0. So from here, you can have it that D equals to 0, and also D minus 14 equals to 0. Yeah, it looks like a kind of quadratic arrangement. So if all of D can be 0, the common difference cannot be 0. So obviously, it's going to be D equals to 14, and there's the final answer. All right, thank you for listening. Do watch out for subsequent videos that will be coming up that I'll be dropping on my YouTube channel. Thank you very much, and don't forget to subscribe. Thank you.